Hello friends and engineers. Today we will see shear force diagram and bending moment diagram. Shear force and bending moment diagram is the essential criteria for the design of beam. Firstly, the nature of beam is determined, which is nothing but the tension and compression in the beam. First, like Civil Studies channel and subscribe it and share to get the enhanced knowledge. In this today's problem, a simply supported beam carries a uniformly distributed load that is the UDL of 20 kN per meter at 1 meter from left-hand support to 2 meters. And point load of 30 kN and 50 kN at 1 meter and 4 meters respectively from left-hand support. Draw SFD and BMD if the total span of simple supported beam is 4 meters. In this first we see steps to solve this type numerical. 1. Take submission of moment at any support is equal to 0. 2. Take submission of all forces is equal to 0. 3. Calculate the support reaction RA and RB calculated from above 2 steps. 4. Shear force calculation take from left-hand support for easy calculation. 5. Bending moment calculation on support and load reaction. 6. Finally draw the shear force diagram and bending moment diagram. So forwardly go for our numerical. For this above steps are used and easily solved. Solving numerical. Before that, like, share and subscribe our channel to get the latest notification of channel. 1. Support reaction. For support reaction, taking submission of moment at support A is equal to 0. Hence, for this clockwise forces are positive and anti-clockwise forces are get negative. Minus RB into 4 plus 50 into 3 plus 30 into 1 plus in bracket for that UDL 20 into acting force is 2 meters and into half of acting span, which is half of 2 plus remaining distance 1 meter is added and this whole is equal to 0. By solving this equation we get RB is equal to 55.25 kilonewtons. Step number 2. Taking submission of all vertical forces. Here notation is vertically upward forces is positive and downward forces negative. A plus RB. Minus 30 minus 20 into 2 and minus 50 equals 0. By solving this equation we get the value of R. A is 64.75 kilonewtons. Apply check for accuracy. Add both reaction which equal to load on beam. Step 3. After calculation of support reaction calculation the shear force at point A, B, C and D. You sees that the shear forces are no. 1. Shear force at a left is 0 kilonewtons. 2. Shear force at a right which is support reaction at A is 64.75 kilonewtons. 3. Shear force at C left is also 64.75 kilonewtons. 4. Shear force at C right here load acting therefore 64.75 minus 30 gives 30 kilonewtons is equal to 34.75 kilonewtons. 5. Shear force at D left UDL also acted hence 34.75 minus 20 into 2 which is 34.75 minus 40 is equal to minus 5.25 kilonewtons. 6. Shear force at D right at which 50 kilonewtons downward acting which is minus getting value minus 55.25 kilonewtons. 7. Shear force at B left is also minus 55.25 kilonewtons. 8. Shear force at B right is always get 0 if it is not get then answer will somewhat wrong. Step number 3, now going for bending moment calculation here which on left hand side clockwise forces positive and vice versa. BM at support A and B is always 0. BM at support C is 64.75 into 1 which is 64.75 kilonewtons per meter. And lastly BM at support D is 94.25 kilonewtons per meter. Weighing to last step drawings shear force diagram and bending moment diagram according to required values. In this shear force diagram at midpoint the point of contrast shear acts that means SF changes from positive to negative. If in question it is mentioned that calculate distance of point of contrast shear from support then calculate. Here the prob will get completed like, subscribe and share the video and channel.